Hello my dear students, welcome back to the St. Joseph Composite PU College, Bijapur. I'm Rahul. I'm a chemistry faculty and in this video I'm going to discuss the basic requirements for understanding the chemical bonding. This is the most important topic and it is, you can say that this is the core of the chemistry. We have to understand that how the chemical bondings are formed. And let's assume that, let me take an example here. Now there are two atoms are there. So this is atom number 1. And there is another atom here, and these two atoms may be anything, whatever they are, the atoms. Now thing is that between these two atoms there is a force of attraction. There is a little force of attraction between these two atoms. Let me draw here. There is a force of attraction between the two atoms. Now this force of attraction itself is called as chemical bonding. So it is a force of attraction. Let me write this: force of attraction. And this force of attraction itself is called here as chemical bonding. It's called as chemical bonding. It's called as chemical bonding. Okay. Now this force of attraction depends upon the various factors. One important factor is type of the atoms. Like this factor depends. Let me write this point here. This force of attraction depends on type of atom, types of atoms. So for example, if there is a metal and non-metal is there, there may be formation of ionic bonding is there. If there are two metals are there, metallic bonding is there. If the two atoms are same, identical are there, or their electronegativities are same, then it may be formation of covalent bond. And therefore we have to write the types of bonds. Let me write the first. We'll discuss that point first. The types of chemical bondings. The first type here is called as ionic bonding. Ionic bonding. That's the first type. The second one is called here as covalent bonding. And the third one is coordinate bonding. Coordinate bonding, and sometimes it is called coordinate covalent bonding also. Next, the next one, that's a D. The fourth one is called as metallic bonding. Okay. To understand the formation, how these the bonds are formed between the two atoms, let's understand one basic information that is the beginning of the concept, that is known as octet rule. The first we'll discuss that. So all these bondings we can, for some extent we can explain using the octet rule. So we'll discuss this part first. Octet rule. This is the first point we have to discuss. Most of the students knew that what is the octet rule. So all the atoms, take an example, atom have capacity or tendency to have 8 electrons in their outermost shell. That is having 8 electrons. Having 8 electrons in their outermost shell. This wording is important. 8 electrons in their outermost shell. Outermost shell. Take an example here. I will take one example. The example is sodium metal. The electronic configuration for the sodium metal we can write like 1s2, 2s2, 2p6. This is 6 plus 2 plus 2, 10. And next one is left, that is here we are going to write 1s2, 2s2, 2p6, 3s, 1 we are going to write. The total number of electrons in the sodium is 11. And we have here 2, 4, 10 and 1 is 11 here. Now you can see that this 3s is outermost shell. Right? Is it correct? 2s2, 2p2 and 2p6, 3s1. This is outermost shell. In that, gaining a 7 electron makes this sodium electron as octet, because only 1 electron is there. No, we can add here 7 electrons, but it is highly impossible thing. Instead of that, what sodium do that? It will convert into Na plus by losing 1 electron, minus E electron. 1 electron is lost by the sodium, and then the positive charge is created on the sodium. Now the electronic configuration or the new electronic configuration of sodium ion is like 1s2, 2s2, 2p6. Now there is no 3s because 3s electron is lost. Therefore, here the outermost shell becomes, that is a 2s, 2 and 2p6. This is the outermost shell where okay, let me close this. Okay. Now here 2s2, 2p6, this is the outermost shell, and therefore what happens here in the outermost shell we have 8 electrons. There are a total number of electrons are 8. There are 8 electrons. 8 electrons. And therefore if you ask me a question that sodium and sodium plus, which one is stable? The sodium plus is stable because in that there are 8 electrons are there. Any atom or ion which having 8 electrons in their outermost shell, they are termed as stable ions or molecules or atoms. Now take an example of Cl minus. The formation of Cl minus. First there is a Cl atom is there, and the electronic configuration for the Cl or the chlorine atom is 1s2, 2s2, 2p6. Okay, after 2p6 a new shell comes, that is a 3s2 and 3p5. So now this 3s2 and 3p5 is outermost shell, and you can see that there are total number of electrons 2 plus 5, that is 7 electrons are there. 7 electrons. And we have to form here 8 electrons in their outermost shell, and therefore Cl converts into, let me write, the Cl is here, is converting into Cl minus by gaining 1 electron, E minus. And right now the electronic configuration for the Cl minus becomes the 1s2, 2s2, 2p6. Okay, next shell, that is 3s2, 3p6 we get, because 5 is there, no? In that 1 electron is added up in the 3p subshell, and we get here, this is the outermost shell. Right now you can see that there are total number of electrons are 8 electrons. 8 electrons. And therefore if you ask me a question out of the Cl and the Cl minus, which one is most stable? The most stable is Cl minus, because in the Cl minus the outermost shell containing here 8 electrons. It means that any atom or ion have capacity to undergo loss of electron or gain of electron in order to gain the 8 electrons in their outermost shell. Let me write that statement here. Atom or ion have capacity, have tendency, or you can say that capacity, we'll write not tendency, capacity to gain how many electrons? 8 electrons. The wording should be important here. 8 electrons in their outermost shell. Outermost shell. Okay, outermost shell. And that can be done by two ways. The first way is transferring the electron, from one atom to another atom. Okay, we can make a simple in simple way we can write that two ways, by loss of electron or by gain of electron. Loss of electron, or the second one is or gain of electron. These are the two ways. By that what happens, the atom or ion get 8 electrons in their outermost shell, and that can be done by losing electron or gaining the electron. So in the previous example you just see that what I have, the sodium lost electron. Here the electron is lost in order to gain 8 electrons in their outermost shell. The Cl gains 1 electron here. It gains 1 electron in order to get 8 electrons in their outermost shell. Hope you understood this. In the next class or in the next video, I'm going to explain that why octet rule is not applicable for all the atoms. It is restricted only up to calcium or the elements which are near to the calcium. Let's see. Thank you students for watching the video.